Hi, my name is Spencer Gardner, and I'm a graduate student in the Department of Forestry and Natural Resources at Purdue University. Here at Purdue, we are collaborating with biologists and ecological modelers from the National Oceanic and Atmospheric Administration, from the U.S. Geological Survey, and from Michigan Tech University to investigate the long recognized but poorly understood relationship between climate conditions and the annual reproductive success in many fish populations in the Great Lakes. This is commonly referred to as recruitment, and in the Great Lakes, we see that fish populations are displaying high interannual recruitment variability, simply meaning that some years produce a high density of H0 fish, whereas other years are not. And so while this is a common characteristic of many fish populations that display and that produce a large number of small, vulnerable offspring, it points to the significance of climate-driven biological and physical factors that must align to create favorable environmental conditions during the early life stages of these small fish. Consequentially, small changes to that environment caused by climate change have the potential to fundamentally alter recruitment dynamics in the Great Lakes, with some species being unequally impacted by its effects. Our research will focus on two ecologically important fish species in Lake Michigan, that being alewife and yellow perch. These species support multi-billion-dollar fisheries and are entirely sustained through natural reproduction. Therefore, it's important to understand how past climate conditions have influenced recruitment success and how future conditions may promote or limit recruitment potential. Our research will bring together a suite of climate, hydrodynamic, and biological models created for Lake Michigan to simulate larval fish dispersion, foraging, growth, survival, and recruitment. The first model, the Great Lakes Atmosphere Regional Model, ties a regional climate model to a hydrodynamic model. That output then fuels a three-dimensional biophysical model that considers nutrient input and allocation processes. These models then drive a Lagrangian particle dispersion model that estimates the transport of larvae with individuals retaining the environmental conditions that they experience. Finally, an individual-based bioenergetics model will utilize the anticipated environmental conditions to simulate complex ecological interactions between each larvae and their environment. Through this coupled and in-series modeling approach, we will not only be able to analyze past climate conditions for its role in alewife and yellow perch recruitment, but we will use this information to forecast recruitment potential under various scenarios of climate change through the year 2100. Thank you for tuning in. I hope you enjoyed this video, and if you have any further questions, feel free to contact me using the information provided below. Thank you.